When machine learning systems fail, most people immediately blame the model. But here's a secret from the trenches of production AI: the model is almost never the problem. The real culprit? It's the data. Think about it. Machine learning systems learn patterns from the data we give them. So if that data is wrong, incomplete, biased, or just plain old, the model will faithfully learn all the wrong patterns. It doesn't matter how sophisticated or advanced your algorithm is. Garbage in, garbage out. It's an age-old rule that's more relevant than ever. One of the biggest traps for newcomers is the belief that more data automatically equals a better model. We hear big data all the time and assume volume is the key. But quantity only helps when the data accurately reflects the real world. Piling on low-quality data just amplifies your mistakes on a massive scale. You're not getting smarter. You're just becoming more confidently wrong. Data problems are sneaky. They don't always announce themselves with big, dramatic errors. They hide in plain sight. Labels might be subtly incorrect, assigned by different people with different interpretations. Crucial features, the very signals the model needs, could be missing entirely. Or the data might be a perfect snapshot of a world that no longer exists, full of historical biases that we definitely don't want to perpetuate. Sometimes the data looks completely fine on the surface, but it's disconnected from how your users behave right now. This gap between the training data and current reality is a huge challenge known as data distribution shift. The world is constantly changing. User behavior evolves, market trends shift, and new, unexpected scenarios, what we call edge cases, pop up all the time. Your model, trained on historical data, is stuck in the past. It slowly, quietly becomes less and less accurate, without ever throwing a single error code. This is precisely why data problems are so dangerous. They don't cause sudden, spectacular system crashes. Instead, they lead to a silent degradation of performance. Your recommendations get a little worse, your predictions become a little less reliable. It's a slow-motion failure that can go unnoticed for months, quietly eroding user trust and business value. And let's be honest, getting good data is hard. It's rarely a straightforward process. Data feeds can be delayed. Information can be logged incorrectly due to a bug. The very assumptions you made when you designed the data collection system might be completely outdated. In many real-world machine learning systems, the data pipeline, the entire infrastructure for collecting, cleaning, and processing data, is far more complex and fragile than the model itself. This is why you'll see experienced machine learning engineers spending the vast majority of their time not on fancy algorithms, but on the data. They're obsessed with how it's collected, how it's labeled, how it changes over time, and most importantly, how to build systems that automatically detect when things go wrong. They know from experience that in a production environment, improving data quality almost always delivers a bigger performance boost than tweaking the model architecture. A better dataset will consistently beat a better model. Understanding this fundamental shift in focus from being model-centric to data-centric is the single most important lesson for anyone serious about building reliable, real-world machine learning systems. It is not about a theoretical quest for the perfect algorithm you read about in a research paper. It's about the practical, hands-on engineering of robust systems that can detect, adapt to, and gracefully recover from the inevitable problems with data. So the next time you think about building something with machine learning, don't just ask what model you should use. Start by asking where your data is coming from and how you can trust it. That's the foundation for everything else. Thanks for watching. If you found this perspective helpful, be sure to like this video and subscribe for more deep dives into what it really takes to build AI that works in the real world. See you in the next one.